Which animal would make the best space pet? Who has priority access to Vera Rubin's data? Is there a limit on how many telescopes we can put in a Lagrange point? And in Q&A Plus, what's the current progress with spacesuits? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Church discography. What kind of animal would make a good space pet? A spider? You know, something that can hang upside down, think in 3 dimensions, has a line that it can use to tow itself around. Now, I've just been reading Children of Time, and by Adrian Tchaikovsky, and that has intelligent spiders in it who eventually sort of interact with human beings. And the spiders are actually in this book are just naturally good spacefarers. So spiders might be good. Yeah, if you had like a tarantula, but I mean, obviously your tarantula is not going to be a great friend to you, but people keep tarantulas, right? A bird, you know, a bird would have to figure out how to fly in weightlessness, but I think they would figure it out quickly enough. So a bird would be kind of fun. But then of course it's going to go to the bathroom everywhere in a way that a tarantula wouldn't. So I think any animal pet that you bring is going to be more trouble than it's worth. James Nguyen, do fish care about living in a microgravity environment? Those might make good pets. Yeah, they've done fish in space, and the fish are disoriented when they first get up into space, and then they figure it out. You know, it's funny. You think that you're in weightlessness when you're in water, but you're not. You're still experiencing the pull of gravity on your internal organs, even though you might be oriented in different ways. And so fish, this is an issue for them for sure. Little fish have been to space and they got pretty confused in the beginning. And then after a while, they figured it out. So yeah, fish would, you know, if they're in water, would eventually be pretty well equipped to deal with weightlessness. I wonder, you know, give the fish a little spacesuit and then he can swim around inside the space station. Tricky Mick, what is the process for flagging and following up on objects reported by the Vera Rubin Observatory? Given how many objects will be reported, do they have protocols to say what gets investigated first? So I think you misunderstand how this works. So there is no they, and there is no protocols, and there are no plans. Vera Rubin's job is to capture these images every single night, and then the data pipeline is sent to a bunch of data brokers. And then the data brokers filter through the information to try to present the information that's useful to their audience. So Vera Rubin generates about 800,000 events a night. So you're looking at variable stars, supernovae, asteroids, comets, planet nines, although, you know, no planet 9 has been seen so far, black holes eating stars, all kinds of things. And then the different data brokers will take that stream of data and then they will make it available in their system in a database. And so you will then perform a query on the data from the data broker and say, show me all of the objects that were brighter than magnitude 15, located in the Centaurus constellation between 5 a.m. and 6 a.m. And then you will get a list of all of the things and the photographs of all of the objects that were taken. So then it's up to you as the astronomer to do your follow-on observations. So you then go and get time on a telescope to observe this object that you're interested in. If there was a supernova you want to do follow-on observations, you then get time on your telescope or on time on James Webb or whatever. And so there is no centralized plan for what happens with all of these data. They are just being disgorged into the internet. And then it's up to the astronomers to do that. And you can do this too. Like you can just go to one of the data brokers. One is called Antares, which is the one from the Noir Lab. And I actually did an interview within the last couple of weeks with one of the people behind this data broker system. And you can access their API. You can write code that queries their system and sends you alerts every time something that matches the criteria that you're hoping for shows up. You know, they try to categorize this as best they can from the Vera Rubin side to say, this was probably a supernova. This is probably an asteroid. This is probably a variable star, but then it's up to the astronomers to actually do the follow-on observation. So, and you can do this too. So you can just build into their API, run queries, find objects. You can then do follow-on observations with your telescope, with your small telescope, to see the thing that was in the Vera Rubin image. So, for example, I've got a bunch of telescopes behind me. So I've got the Seastar and I've got the Vaonis telescope. Both of those are capable of seeing down to magnitude of like 15. And so Vera Rubin is finding thousands of objects every night of magnitude 15. And so you could pick one of those objects and then you could do a follow-on observation with a small telescope and confirm the discovery of a supernova all by yourself. There's no centralized group that decides whether or not you're allowed to look at the Vera Rubin data and point your telescope at the sky. And I think there's too much. Like it's hard to get across. If you want to discover asteroids, you could just do this. You could find thousands of asteroids a night if you wanted to, just by looking through, writing code. It is a gold rush right now. You could probably discover comets, and maybe you'll be the person who discovered Planet 9. Get to work. It's time to shout out our new patrons at the $5 level and above: Nomadic Synth, Todd Moeller, Janice Green, MK, Dave B, Shazad Nakota, Sebastian Delanchier, Telescopes Canada, Oralgo, and Richard Sharp. Join our community at patreon.com/universetoday. IARC-SIM, researchers from countries that funded Vera Rubin will get first access to that data, right? I thought the general public would only access data up to a month or two ago, right? No, it's all live right now. You can go, there's tons of people built really cool gadgets for processing data from Vera Rubin. You can go to the data brokers. I think there's 7 data brokers. You can pick the one that you want. One specializes in, supernovae, variable stars. Others specialize in things in the solar system. And you can start querying it. It is publicly available. There's no gatekeepers on this whatsoever. Nope. Everyone, it's free to access it right now. The only check is that it goes through the Department of Energy and they run filters to remove military satellites from the data. So they remove those alerts from the data. Apart from that, it's free to use. Go crazy. Frosty Winnipeg, could a telescope on Earth use the moon, new or crescent, as a star shade? No, but there is an idea that you could launch a star shade that telescopes on Earth could use them. So there's actually a NIAC grant that was awarded a couple of years ago, and this is sort of making the rounds again. There's a new paper that just came out about how instead of needing to launch, say, the Habitable Worlds Observatory and have it have a separate star shade that it uses, you could have a star shade that you just launch that is then used by observatories on Earth. And it would have to follow a very specific trajectory and would kind of loiter in front of the star that you want for as long as you can before it runs out of propellant. And so there's some really cool ideas about being able to do that. We could do a lot of really interesting tests in the short term with these star shades. So hopefully before we see the Habitable Worlds Observatory launched with a star shade, we'll have already seen a star shade launch. I think their estimate was it would have to be about 100 meters across. It would be, very thin. It's an engineering challenge, but definitely within the realm of what we can do. It doesn't have to be very thick. And then you could use, say, the upcoming extremely large telescope. It could use that star shade to be able to directly observe planets orbiting around a sun-like star. So hopefully we'll see a star shade launch long before we see HWO. Terry Hardaway, did 3i Atlas have any effect on objects in the Kuiper belt? Could that have happened to a planet rotating on its side? Any other orbital anomalies? So Comet 3i Atlas was maybe 5 kilometers across, maybe 10 at the most. So it was not a very big asteroid. And so it had a gravitational interaction on objects in the solar system, but almost none. Like it may have caused nanometer changes in the orbits of objects in the solar system, and then it was gone. Isn't it weird that we haven't heard anything about 3i Atlas anymore? I wonder what happened to all the people who were wondering whether 3i Atlas was an alien spaceship or not. Have they found something new to wonder about being an alien spaceship, or have they just gone quiet? It's interesting. I wonder. I don't care enough to look, but I wonder. But yeah, so 3i Atlas was moving very fast and didn't have a lot of mass. And there are plenty of asteroids with much more mass than 3i Atlas. It's just another rock moving through the solar system. Casey Ream, will spacesuits ever change much? So there's some really cool ideas for the upcoming spacesuits. So the Axiom spacesuits that are being developed for NASA for the upcoming Artemis missions have a really interesting feature, which I am going to explain. Normally, when an astronaut wears a spacesuit, the problem is that you have to balance the internal pressure of the spacesuit. So if you try to just say inflate your spacesuit to normal oxygen levels or to normal atmospheric levels, then the spacesuit is kind of like a balloon that you're inside, a rigid balloon that you cannot move in. And so what they do is they actually inflate the spacesuit to about a third of its normal pressure. Now, this isn't enough atmospheric pressure for the astronauts to breathe. And so they put them in an environment of pure oxygen. So they have 100% oxygen and then a lower air pressure. And so now they can move and be flexible inside their spacesuit. The problem with that is that you have to take time. It's sort of similar to how divers work with you have to adjust your body to that lower pressure environment and then to come back from that lower pressure environment to the higher pressure environment. And if you don't, then nitrogen bubbles can build up in your joints and you can get what's called the bends. And so they have to go through this process where your body will essentially push out all of the nitrogen so that you then don't get the bends. And so with the Axiom spacesuit, the idea is that it'll have a range of pressure capabilities. So you'll get into the spacesuit and it'll be at normal atmospheric pressure. And then it will slowly dial down the pressure in the spacesuit while you're beginning your spacewalk. So you're walking out onto the surface, you're starting to interact in the environment. And then it'll get you to the sort of target pressure. And then before your mission is over, it will bring that pressure back up. Sometimes the astronauts will sleep in the airlock just so they can save time when they actually have to begin their spacewalk on the next day. And so you can imagine with the upcoming moon mission, the astronauts will get into their spacesuits. They'll start to bring down the pressure and they'll be able to just go out onto the surface of the moon and then come back in and then bring that pressure back up. So it's a very cool idea. And so that's one example. The other idea, and this one is, people have been trying this out, but no one has been able to really kind of pull this off yet. But the way spacesuits work is that they put an artificial environment, an atmosphere around your body, because if you don't have that atmospheric pressure, it's very bad for your skin. Bruising, internal bleeding, it's very bad for you to not have that pressure, the atmospheric pressure. But air does it. You've got the entire column of the Earth's atmosphere bearing down on you on, 15 pounds per square inch. You've got this pressure of the entire atmosphere of the planet pushing down on every part of your body. And they simulate that with the spacesuits. But you don't need atmosphere. What you actually can use is elastic. You can use some kind of system that essentially pushes against your skin with the same amount of pressure as the atmosphere does. And so people are designing suits that are sort of they look more like bodysuits. They're very sleek, very, very kind of futuristic looking. And so you don't actually need to have the big bulky spacesuit. Now you would still need some kind of helmet on so you could breathe. And one of the real challenges is at the joints. So, you can say surround your forearm in this elastic material to handle the pressure issue, but you need to be able to have a joint like your elbow and to be able to, and that's a very difficult to just sort of imagine how hard it would be to have something that is always perfectly, continuously putting the right amount of pressure inside your joints. Places like inside your groin, inside your knees. So those are the challenges to that idea. But there's a woman at MIT who is working on a bunch of prototypes and has sort of gotten things pretty far along in that development. And so it might be that they'll solve this with some kind of materials or maybe some kind of hybrid approach where you've got you've got the elastic material for the parts of the body that you can do that. And then you've got, pressurized joints or something like that. But it's a very cool idea. So yeah, there are still ideas. But in general, a spacesuit is a little spaceship. You're bringing a little piece of Earth with you. And there's only so many ways to be able to do that. Did you know you can watch the same video, but with no ads, and get a bonus question over on Patreon, completely for free? We call that Q&A+. And this week's bonus question, is there a limit on how many telescopes we can put in a Lagrange point? I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank you, everyone who asked your questions into the YouTube comments, everybody who joined me for the live show. There should be an event here on the channel for the next live show that we're going to be doing next Monday. I'm going to chat about 2 big lists that I put onto the channel. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Barely Griffing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bielek, Cooper Nelly, Darkfinger, David Gilton, David Metz, Evan.pro, Greg Feely, James Clark, Janice Smith, Jeremy Matter, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Nordspace, OneStepForAnimals.org, Rank Haidu, Richard Williams, Sean Sargent, Stephen Fadley-Munley, Team 49, Telescopes Canada, Vlad Chiplin, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I have been teasing for the better part of a year now that I have put together a list of my favorite movies and my favorite television shows, my top 100. And people have been asking me when I'm going to release these lists. And so I finally released these lists. There are links to them down in the show notes over to Patreon so that you can see the 2 lists. And like a couple of caveats, because this caught a lot of people off guard. First, they are alphabetical. So I am not going to tell you which are the best out of the list. I'm not going to put the entire list in order yet. Maybe I will do it someday, but I just don't want to micromanage and have the conversations. That if you see it on this list, then I consider to be one of the best sci-fi, fantasy, space movie or television show ever made. And these are my top 100 of both. The list also contains 104, 106 items right now because it is still in progress and people have given me some feedback. I forgot Red Dwarf for television shows. People are making the case for Annihilation and other movies. And so I'm considering that. And eventually I will end up with my final list of 100. And then I think as new movies come out, say Project Hail Mary, although I put it on the list, but if a new movie comes out that I like better than one of the ones that's on the list, then I will pull one off. And so my list will remain constant. So go ahead, check out the list. Hopefully there'll be a bunch of movies in there that you've never seen, and definitely television shows that you've never seen. My tastes are pretty obscure in some cases. I've got stuff that you probably have never heard of. And so you might be able to find some new stuff, which will be great. So thank you everyone who gave me the feedback. And this is going to be a living list from this point on. And I'm going to come up with some cool way, maybe something visually here where you can actually see the list. And I'll go through the process of removing items and putting them on. But hopefully, and then I'll work on my books. But that may take me a while. All right. We'll see you next time.